Okay, in this video I'm going to review the topics from our series and sequences chapter to help prepare you for the final. First of all, one thing that students are often confused with is how exactly we use sigma notation. So let's break down what this means. First of all, the weird looking S is our sigma sign, and the n equals 1 is the first value. The 8 at the top is the last term that we are going to find. If the formula that we're given is arithmetic or geometric, then we can use the formulas for this for the finite sum S of n that we'll review in the bottom of the page and take it from there. If it isn't, then what we need to do is we need to add all of the terms to find the sum. When we look at this problem here, this problem is not arithmetic or geometric. It is simply just a formula. So if I were to evaluate this, I would start with n equals 1 and I would plug 1 in, and my first term would be 3. Then when I plug in 2, I would get 6, and then 11, 18, 27, 38, 51, and 66. Sorry, this is so sloppy. And my final sum would be equal to 220. There is no shortcuts to solving this problem because it is not arithmetic or geometric. Now when we're trying to determine what kind of series we're looking at, if we are trying to determine arithmetic, what we look for is that each term increases or decreases by a common difference. In order to find this difference, we are going to subtract consecutive terms. We can subtract any two terms to find that common difference. One of the things that we talked about is that problems that are arithmetic look linear, meaning they follow what looks like a mx plus b type of format. The explicit formula, a sub n, is going to be your first term plus n minus 1 times that common difference. Now we have a sum formula, s sub n, which is equal to n divided by 2 times a1 plus an. And then what this does is this sums the first n terms starting at n equals 1. Now we want to recognize this in sigma form as well. So what I mean is, let's say I gave you the problem, the sum from n equals 1 to 22 of 6n minus 3. I would want you to recognize that this formula is arithmetic. We know that it's arithmetic because, number one, it looks linear, and number two, if we were to list out the first couple terms, we would see that each time the terms are increasing by 6, because 6 is the common difference. With any arithmetic series, an infinite sum does not exist. This is because the series is divergent and never converges to one number. Alright, so next up is geometric. Now when we are looking at our geometric series, what we will see here is that each term increases by a common ratio, which we call r. And to find that common ratio, we're going to divide consecutive terms. The explicit formula for a geometric series is a sub n equals my first term times r to the n minus 1 power. Notice the differences between arithmetic and geometric. You are always starting with your first term, and then in arithmetic we are adding additional differences. In geometric we are multiplying by additional differences. When we are trying to recognize these formulas, we will recognize geometric because we will see a constant, I spelled that wrong, a constant raised to a variable power. And in contrast to our arithmetic up here, we see a constant times our n. Okay, so with arithmetic it's a constant times n. With geometric it's a constant raised to an n. Now it could be raised to n, it could be raised to n plus 2. The important part is that it is a constant raised to a power. Now if we recognize that it is in fact geometric, then we can use the geometric sum formula also. And our geometric sum formula is that s of n equals the first term times 1 minus r to the nth power, all divided by 1 minus r. Now notice here that my r value is raised to the nth power before it is subtracted by 1, and that is very important. Now with our infinite sum sometimes exists with our geometric series. What we want to look for is if the absolute value of r is in between 0 and 1, then the infinite sum exists, and we can say that the sum is equal to our first term divided by 1 minus r. And this is called a convergent series. If the absolute value of r is greater than 1, then our infinite sum does not exist because it is divergent. Last up would be our annuity formula. And our annuity formula is one of those things you just have to memorize. We have r times the quantity 1 plus I to the nth power minus 1, all divided by I. And in this formula, S stands for the future value, R stands for the payment that you're making or deposit you're making each month, I is our interest rate, and we always want to write these interest rates as a decimal, and then N equals the number of payments made. Alright, good luck with your series and sequences.